By the way, also think about how you would fix the problem if you think that there is a problem with this data set, right? Yeah. Okay, I see discussion dying down. Maybe it's time to start this. All right. We'll be back here, back of the attention, bring back your attention to the screen. Now, some examples, what is, I mean, yeah, that's the thing. You may think that, well, I may think that this is a super messy data, but this actually happens. I mean, this may not be, this may be like a little bit exaggerated, but many of the problems that you can find here actually happens in a lot of, especially collaborative works. When you have multiple data and multiple people doing the data entry, a lot of these things can happen. All right. So yeah, some of the examples, like what do you think is wrong? How would you fix it? Yeah.
I think the 2013 spreadsheet is completely segregated by species, but the 2014 is segregated by the plot.
That's right. That's right. Yeah. And that is a problem of when you have table associated with different attributes. Remember that what we really want is observation, attribute of each every single attribute of the observations in one row. Okay, in this case, the table itself carries an attribute, and then there's like multiple columns, and each column carries additional attributes. And that's not what really what we want. So what are the problems with this set of data? Oh no, wait, how do you fix it? How would you fix it?
I think I'd decide which one I wanted to do it by. And I think it's easier to do it by species just because there are fewer species than plots.
Okay.
I think there are 7 plots or so.
That's right.
So it's easier by species than plots, and then we put both of them together.
So you want to have
just an entire column, just 6 species.
Okay.
And then
so you want to have something like that, but you organize the 2014 data according to this format.
Yeah.
All right. What could be wrong of that approach? What could be wrong with that approach?
Hard for a machine to read.
That's right, yeah. Hard for machine to read. And again, as I say, key rules, you don't want to associate one table with additional attributes. You want the attributes to be associated with a row, not an entire table. So in this case, if I were you, I would add an additional column here.
Yeah.
Species. Yes.
Yeah, that sounds right.
Oh yeah. Oh yeah, that's right. Okay, and then I can remove the first row that says species DS. Okay, what other problems that? Yes. Mhm. That's right. Yeah. So the other problem is, especially in Excel, this is not just in Excel, but all of the software programs will tell you something is wrong with this. These things in Excel, you can see that it's right aligned. That means these are numbers. These are recognized as numbers. But these are not recognized as numbers. These are recognized as text. That's why it's left aligned. All right. So, and you don't want to do that. You want consistency throughout your data set. And also, well, the data column says weight. You expect a number. You don't expect a text. And that's why you should move the grams to the column header or the column header or the attribute names. What else? There are actually a lot of problems. This, yeah.
Would the scale not calibrated?
Mm-hmm.
Include that, you have to trust it, you don't trust the value, how it should include it.
Yeah. But I mean, that's the thing about being an ecologist is that sometimes you still want the data because data is precious and rare. So that's why a lot of us sometimes we will still record this information. Maybe we'll let the whoever analyzing the data to deal with this problem. But you point out a very important information things here. Again, these things is recognized as text. You don't want this to happen. Secondly, what happened with these two cells is that you're not recording one information. You're recording two information in one cell. And that is not fun. And that is something that we should all avoid. Okay. One cell, one column should record one information, one set of attributes, not more than one attribute. And that's why in this case, this is actually two information. It carries the information of the weight, and it also carries the information that scale is not calibrated. Okay, how would you want to deal with this problem? Sorry? Yeah. So you can add another columns. It can be like calibrated question mark, and then you have like yes, no, yes, something like that. All right, to deal with this problem. All right, what other problems? Now we go to the 2014 sheet. What other problems do we have?
I think one of the tables says 1978. I think the plot 4 table actually has a 1978.
That's right. Yeah. So the plot 4 tables down here. One of the problems is that there are multiple problems here. First of all, it's 1978. What is it doing in the 2014 sheet? Okay, it shouldn't be there. Something's wrong. Secondly, we have a problem of one column carrying two informations, again, species and sex. And then we have inconsistency in the column headers attribute names, because you can see that everywhere else weight is spelled as WEIGHT, whereas over here is WGT. All right. But there's another another problems that we see here that we should avoid at all time. Right in the center of the screens. What's going on here? What? Right. So again, these two cells actually carries two information in one cell, which again is not a good practice. And I should add it here. One cell, one attribute. Okay. But more importantly, we have to avoid at all time using formatting to convey an attribute. In this case, you're using gray cells to mean an additional information. Measurement device is not calibrated properly. Why is that so? Because computer likes to read text, numbers, text. Computer don't like to read formatting. Bold text, it's going to be very difficult to tell the computer to say, oh, this thing is bold, it means something else. Or this thing has a gray cell, it means something else. It's going to be much, much harder for us to instruct the computer to say, to do something extra about these things. So we should avoid that at all time as well. But more importantly, for the whole data set here, it violates basically the first rules that I just set out earlier. Data should be rectangle. This is multiple rectangles and multiple sheets. 1, 2, 3 sheets. So these are definitely not rectangles. These are some hyperdimensional rectangles. And it should be avoided at all times. So our data should, so how do we deal with this problem? Copy and paste everything, consolidate them into a long rectangle. Okay, because we have identifiers like this, our dates have 2014 here. Why do we need a sheet, extra sheets to record this information? All right, and of course there's also problems like this where the dates doesn't have years here. So when you consolidate them together, you need to add additional 2014. And then for this, it's quite hopeless. I'm not sure if it's a typo or something like that. And, these are something that when we do data entry, when we do data organization, data cleaning, we need to decide, is there something wrong here? All right?
Quick question.
Yeah.
You said that the computer only lets us see numbers. What about things like dashes? And
oh, dashes are considered text characters.
Okay.
Yeah, so it's fine. Yeah. So computer can read all those things. It's harder for computer to read color, for example, or formatting, italics or bold or highlights and things like that. Yeah. So yeah, a good looking data table in Excel sheet should be black and white and should be rectangle, and it should have only one sheet, hopefully. Sometimes we will have multiple sheets, but I'll talk about how later on Excel is not actually a good format for importing and exporting to other programs. All right, but that's why I'll go back to my original data set, my toy data set. Now, what can be wrong with this, and why would I not be happy with this data table? That's right. Yeah. So there are multiple information in my model. It would be fine if I don't care. If I see that Volkswagen Jetta 2001 as one model and the other model, say for example, if I have Volkswagen Jetta 2002, I see it as a distinctive model, then it would be fine. But you never know. This kind of data set is not flexible enough. You want to make sure that maybe some year down the road, you're actually interested in Japanese brand versus Germany brands. Then you would want to segregate or separate the information of Toyota out of Toyota Corolla 2006. And that's why it would be great if we can have additional column here, make and year, that stores singular information. All right, something like that. So this is the key parts of our of the data organization using Excel. Some of these rules I hope that we can remember and apply to whatever our research on in the future. Just a little bit more about using spreadsheet. When you have thousands of lines like this, sometimes when you do corrections, you tend to do this. Okay, and sometimes you may do something like, oh, this is not supposed to be 2300, this is supposed to be 1600. And then you just accidentally move it over to here, 1600. And something like that can cause a headache when you have thousands of lines. You don't know what's going on. And that's also why sometimes people advocate for other type of data entry using databases and whatnot. But in Excel, when you suspect, sometimes you need to do some quality control with your data. In this case, if I have thousands of lines, but how would I be able to do a quality control on the weight? Any suggestions? If, say, for example, now I suspect something's wrong with my data, I want to check if I want to pinpoint maybe there are some typos, maybe there are some errors, how would I be able to do it based on this set of data, for example? That's right, yeah. You can make a graph out if look at the outlier. You can also just sort this particular column. Do a sort A to Z. And then, well, it happens that my numbers are from smaller to bigger, that's why nothing moves. But yeah, and then when you drag all the way down, you'll be like, no, there shouldn't be a car with 21,000 kilograms. That's maybe a tank. Shouldn't be a car. So yeah, so these are some of the ways that you would want, yes.
So right now you sorted only on C, and then got all missing.
Yeah, so that's so in the if your data is in rectangular format, yeah, the newer versions of Excel allows you to choose only a specific row column and sort it, and it will automatically sort the whole rectangle instead of sorting only that particular column. Yeah. So these are some of the techniques that we would want to do when we do. And in fact, before we use our data, we should be actually looking at doing some quality control like this to make sure that, well, you have, say, for example, I hire 3 undergraduate students to enter the data. You should check it, definitely. Yeah, just to make sure that everyone is doing the same things and whatnot. All right, so that will be the quality control. And finally, I will talk about, so now I have a data. Okay, I have let's assume this is a good looking data table. So now I want to share it. I want to use it for other programs. I want to bring it to Python. I want to bring it to other, I don't know, SPSS, statistical softwares, for example. Of course, obviously, the easiest way is to go to File and click Save As, and save as an Excel workbook. All right, the default version, the default choice is Excel workbook. All right, many of the modern softwares nowadays actually have packages or converters to convert Excel workbook into the kind of data format that our software likes. But you know, to ensure cross-platform integrities or compatibilities, usually we prefer to use this particular format called CSV or CSV, comma delimited. Let's see. There are multiple versions of CSV. Well, CSV stands for comma separated value. So imagine the tables that we see here. In that particular format, it will be ID, comma, model, comma, weight, parenthesis kg, comma, remark, comma, make, comma, year. And then the second line would be 1, comma, Toyota Corolla 2006, and so on and so forth. So this is one of the very common ways for us to interface, for us to export our data and push it to Python, R, or other statistical software or other programs. Simply because it is simple, it doesn't store additional informations, and that is also why you don't want to use color or formatting to convey information, because these colors and formattings is not stored in CSV files. Okay, CSV files is exclusively for, it's basically a text file. So say for example, I save it as DC workshop. I save a CSV format in CSV format. Now you see multiple versions of CSV in your file format here. UTF-8 means that the Unicode information is stored here. So things like Chinese characters, words with accents, umlaut, was it tilde on top of an N, for example. These are all stored in the CSV format. But if you choose other type of CSV format, like comma separated values, Macintosh, MS-DOS, comma separated, those informations are not, those kind of characters is not stored. I think you can even store emoji using the UTF. Yeah. So or Nano or Vim, and you can actually see the CSV file. It's exactly what I said just now. Something, comma, something, another line. So these are purely text files. It has smaller, the file size is definitely smaller compared to Excel workbook, for example. And it has clean informations, no formatting, nothing about colors. But it's the kind of data format that we prefer when we do next steps, data analysis, data manipulations, and whatnot. All right, so that will be the end of this particular sessions about spreadsheets. Later, I'll talk about OpenRefine. If you haven't installed it, if you have problem with OpenRefine, talk to me or talk to one of the helpers, and we try to figure out how to deal with these installation problems. But OpenRefine is a tools where we use it for, it's an additional tools that graphic user interface based tools that we use it to do data cleaning, a little bit of data explorations, a little bit of quality controls as well. All right, so let's take a break of 10 minutes maybe. Grab some coffee. I know I. Oh yeah, thank you.
Let's make sure to this is really good. That's what we're
Is it ever a good idea to use Sheets? What happens when you save a Excel file with Sheets as CSV?
With Sheets.
So if you have like 10 sheets and you save that as CSV,
It will only save the active
It will
sheets.
only-
Yeah, that particular sheet. So, I mean, yeah, these are the things that you don't. That's why you don't want to work with multiple sheets
No.
of workbooks as well. Yeah, it's like
it's not.
not advisable. Wait, so you don't really use spreadsheets for data,
I mean,
or because like you
just
don't
for
have data?
spreadsheets like this, right? But like in my work, I never really use a lot of structured data. Like the kinds of data that we deal with are generally like data from simulations, from numerical simulations.
It's like you already have the
Yeah,
format.
so basically you are saving like velocities, pressures, whatever as
Yeah.
big files, and generally they're just one
Yeah,
big column
yeah,
of
they
data,
want just
right?
big columns
So
of data. Yeah,
that's
You
really
don't
the
really need that,
most
yeah.
type of data that I deal with. So
yeah. I also, I mean, like right nowadays, my research is based on like downloading data out of the internet, so it's already formatted
exactly.
most of the time.
I don't actually find myself using spreadsheets, though. So I didn't lie there. It's the truth. And I don't know how to do a lot of things with Excel.
No,
Just
yeah,
never used it.
and it's like, yeah, well, data carpentry. We try to not do things
No,
using
but these are really important things.
Yeah.
So I'm really glad we talked. And for plotting, I've never used Excel to plot.
I think maybe like 3 years ago I would still use Excel to plot a lot of things. It was only when in fact it was because of the ggplot that makes me like to plot with R a lot more.
Yeah.
Because the base functions for R is like, you have to think about a lot of things, like a lot of small little things,
Right.
and you need to
So-
think about.
Yeah, it's a lot like MATLAB.
A lot like
I
MATLAB.
like the ggplot philosophy.
Yeah.
Where you don't really worry so much about how the plot is laid
Yeah,
out. You just say what kind of plot you
Yeah,
want.
you don't even need to worry about like the aesthetics and whatever.
You know. So Brandon said,
Which research?
the two first. So the two first is also do you know what? So Brandon says the two first. Those are two pronouns on the second floor.
Yeah, there's okay. It was that's great.
Yeah, sounds good. I don't know that information from my class. I don't know. No, you're fine. I would like to go ahead. And also to be strong.
What's your go-to?
What? But why? Huh? Okay. Welcome back.
Everyone has OpenRefine installed and fire up. I hope. Okay. All right. So a little bit about OpenRefine. OpenRefine used to be Google Refine. The idea of Google Refine, OpenRefine now, is that we have an graphical user interface, very much, well, similar, not very much, similar to the spreadsheets, the Excels and whatnot that we have been using. But it is powerful in its own way because it can deal with hundreds of thousands of lines of data, rows of data. It allows us to do some of this data cleaning a lot easier than using Excel. But it is not a coding language. It's not like a command line kind of language yet. And this is quite helpful for actually some people who who have a phobia of codes or command line. I actually learned about OpenRefine when I'm here in the United States. I think back in 2017, actually last year. Yeah, and one thing that I quickly do is I actually texted my ex-colleagues. Wait, you guys should be using this instead of Excel to do your data manipulations and whatnot, because OpenRefine kind of sits in between Excel and some of the code, Python scripts or R and whatnot. So we'll look at some of the useful functions about OpenRefine. And it adds to like additional tools for you to add into your research workflow. For me, I'm not that used to using OpenRefine anymore because now that you know how to code and you know how to use some of these functions, you kind of slowly graduated from OpenRefine. However, there are some useful functions within OpenRefine itself that sometimes we actually fall back to using it. All right. So OpenRefine is written in Java language. So what the whole package of things doing is it created a virtual server in your computer, and that's why we access to that particular virtual server using our web browser. And so all of our workflow is going to be based on web browser here. So yeah, there's the Etherpad. Have you? I hope everyone downloaded the files already. It's a pretty huge CSV file, and let's see. Well, let's open it using Excel. So the good thing about CSV file is that Excel can handle CSV file, and it will look like an Excel sheet once you open it. Because it's a huge file, Excel is actually doing quite a good job. It's already showing up here. Yeah, so these are the data. Go. Okay, so don't know how many hundreds lines of. Okay, so it's about 35,000 of rows of data. Each of these data is kind of like extensions of the messy data that we work on just now. Ecologists go out in the field when you encounter these particular animals, take the locations of the animal, where are they, identify the species, record the localities where you encounter it. In fact, some of them even have latitude and longitude of the locations, the county, the states, and the countries that you encounter these animals. And then there are some unique identifiers of like which plots is this and what are the survey IDs, the month, the day, the years of the survey, so on and so forth. All right, and we will do the same thing and open it using OpenRefine. Yeah. So if you go to OpenRefine, if you have no other projects, it will default goes into create project, and this is where we can browse and look for the our CSV file. Download. And point to the files that we just downloaded, and we upload the file. So we upload this particular file, this CSV file, to our virtual server. So it's like uploading your file into your computer, but different compartments of your computer. So once you click next, it will upload, it will update the previews. So OpenRefine tries to understand your file format and show you, okay, we think that is a comma separated version of the file. And say, for example, you know that this is actually tab separated. So apart from comma separated, there are also similar file format, text file format, but instead of using comma, it uses \T. That means tab. All right. So if you do that, you can see that the preview come up with gibberish things because this is supposed to be a comma separated and not tab separated. All right. So and there are a couple of choices as well. Like you can ignore the first few lines of the files, and this is actually quite useful if, say, for example, you're dealing with logger data. Some of the logger data has the first two lines, for example, as some sort of like a unified identifier of of the loggers, things like that, and you might want to ignore the first few lines, and you can do it here. So these are all in graphical user interface. When you go down to, say, using Python to import data like this, you would obviously have to put in the right arguments in the right place to tell the computer, ignore these lines. But in our case, everything looks fine, and we are just gonna create the project. Project names. Let's make it sound nicer so that we know what's going on. I will call it Portal Rodents. Portal is a project that a bunch of ecologists working in Arizona, they have created demarcated a plot for. Oh, I'm sorry. I've always been doing that. Okay. No. Okay. Yeah. So we'll create the project. Once you created the project, it comes into this project view. Right panels is how the data would look like. And the left panel is sorry. Yeah. And the left data is panel is where we will do some manipulations of the data to and the outcome of the manipulations or outcome of the explorations will appear on the left hand side. So one of the, well, as you can see, the two tips here already tell you using facets and filters, and this is the main function of OpenRefine. Facets is a very useful tools when we want to understand our data, our columns especially. So in this case, for example, I want to know I want to create a facets of scientific names. You can actually go to the scientific name column. There's a drop-down button. When you click on it, facet. In this case, I want to create a text facet. It's very difficult to explain what is facet, but when you create it, you would know what's going on. So what facet does is it looks at every single values of the scientific names, and it tells you how many of among the whole of the columns has a value that calls Amospomophyllus harrisii, for example. And in this case, there will be 435 of them. Then you have Amphispiza bilineata. There will be 289 of them. But something strange is going on here. What do you think might happen when you see this kind of, yeah. There seem to be some typos because there are scientific names that is one alphabet away from each other. As a biologist, I can tell you it's rare because everyone likes to come up with very interesting and different names instead of coming up with something that's like so similar to each other. So there seem to be some typos around here. And this is a good tool. Facets allows us to look at this and say, well, yeah, maybe these group of values, they are indeed actually one species instead of like having I don't know 1, 2, 3, 4, 5 of them being in the same being in a different species. Sorry. So that's what facet can do for us. And
I'm not sure if in your professions or in your expertise you would deal with this kind of data, but this is super common for biologists. There are so many typo errors in biological data, especially when it comes to scientific names. And yeah, that's what leads to there are some debates about why do we still want to use scientific names. Nowadays we can just use A12380 or something like that to refer to a specific species. Okay, the good thing about facets is that if you hover to say one of these, you can actually click on edit and you can correct the name to say, for example, we will stick to the one that has 289 count. We think that since they have the most count for these particular names, this should be the most correct one. Or at least when you got it wrong, you got everything wrong altogether. Then you can fix it just in one shot, you know. So we can just do something like that, bilineata. Okay, we can fix the name. And once we apply it, you can see now the Amphispiza bilineata now have 290 count. We have sort of like changed the values of one of them to the others. So the other disappeared and this one has added with one more count. So what's good about this is that you don't need to look into this column and find out which of them is actually spelled wrongly and correct it accordingly. So you can actually come here and just choose edit and correct the names and whatnot. All right, so that is facets. Now, facetting is so now let's do a little bit of an exercise. Can you tell me which year? So among this record, which year has the least count? That means maybe we encounter the least animals in which year? Would you be able to do that using facets? So year would be the YR column. All right, so spend 1 or 2 minutes and tell me which year is the least, has the least count of animals, of rodents in this case. 1977. I don't know. Anyone agree with that? Okay, good. Okay, yeah, because we can use facet and facet. So yeah. Well, one way is you slowly look at each of these numbers and find out that 1977 have only 503 counts, and that would be the least amount all the other years listed here. But of course, you can also choose to sort by count. Okay, if you sort by counts, in this case, it will be the highest will be 1997, and the lowest will be 1977. But it's interesting. It's a year. It should be number. Why are we creating text facets for it for a number? What happens when we do create a facet, numeric facet? No numeric value present. Okay, so what happened is that when we import the data, OpenRefine by default says that everything is text. Every single column is text. And that's the reason why this particular column here, although all of them are numbers, they assume that it's a text. And that's why there's no numeric value present here. So how do we do that? How do we convert this to numeric? We can actually go to the year column now we realize that the value becomes green in the right line. This
So in this case, this is a year as opposed to a count of 1,900.
That's right.
But it can't, does it make that distinction?
No, it doesn't. It just says that this is a number. Yeah, it can be any number. Yeah, but
So a year may not be one that you want to convert to.
sorry.
The year may not be a number or a value you want to convert to numbers rather than a data set or data point.
Right. Yeah. So, yeah. And now if we look at on the left-hand side, you can see something going on here. Our numeric facet now has a fancy well, this is not really histogram, but maybe a bar plot, I would say, or a frequency plot. Okay, and it will tell you from 1977 to 2003 for each year what are the frequency of the or the count existed in this data set.
What did you click with this history?
So just now I created a numeric facet. So yeah, another good thing about this is you can go to undo redo tab and you see what's going, what did you do just now? Okay, this is a very important aspect of OpenRefine is that it records every single step. What have you been doing? And you can look at the history and you say, go back. Okay, this is mass edit. And I come back here. I created a numeric facet, but because this color more numeric value to present here. But once I change the year from text, I transform it. I use edit cells and then go into common transforms. Sorry, to number. Now the whole column becomes numerical. And now the numeric facet has something to show us. In this case, it is a frequency bar plot. All right, so that is different kind of facets that we can do. So now, let's look back at the scientific name. There seem to be multiple cases where there might be typo error. Okay, if you look at Amospermophilus harrisii, there are, again, you kind of see that there are multiple counts of very similar entries. Likewise, Amphispiza bilineata. Imagine if you, I mean, over here, I think we have 27 choices. That means we have roughly 27 different unique names. But what if we have hundreds of them? Then you will have to slowly go through them one by one. Okay. And the good thing about OpenRefine is we can actually click on the cluster button. Clustering. What clustering does is it looks at the different entries, and it does some sort of statistical analysis with the text that you are given, and it says, okay, what's the distance between these two unique values, and what's the distance between all the other unique values, and you can choose different methods here. There are different sorts of algorithms to calculate the distance between the two unique values. And it will say that, okay, after a certain threshold, we will say that this group of values are very close to each other. They might be the same. And that's why what is listed here is these three values are so close to each other that they're clustered together. And it will be up to you to decide whether or not these three values should be, in fact, merged into one value. And in this case, I suspect I should be merging it. And I'll click on the merge. Based on new cell value, I think it's based on the first spelling. Looks right, yeah, based on the first spelling. And then I will merge selected and recluster. Or merge selected and close. Whichever, yeah, maybe we can merge selected and close. And again, if you look at Memphis Pizza by Lineata, now it becomes 292 counts. But you can see, right, there are still additional 7 counts up here, 1 count down here, another count down here. Basically, the algorithm says, well, they're still some distance away. We're not sure whether or not they are the same things. So when you do cluster, when you click on cluster again, you can choose on different keying functions. It's based on different algorithms, different methods, different functions. Get this back. It's weird. Like,
Let's let it go up and then turn it back on.
yeah.
Sorry about that.
No. It's like, all right.
Turn it off and turn it back
Yeah.
on is the key to any troubleshooting.
Yep, that's right. Yeah, it's also a signal that like you have been talking too much. Yeah.
Do you talk about the phonetic matching? I just found that. It's pretty cool.
Yeah, it's cool. Yeah, and no, I don't know.
Let me go grab. I think it should be fine.
Yeah, seems like it's starting. But it says no input right now. No, wait, but it says no input. So. It says no input.
Can you check your Mac display settings?
Okay.
There it is. Okay.
Okay.
And it's alive.
Cool. Boom. Oh, okay. No, it's just going mad right now. Mad at me.
You think it's here?
Doesn't seem like it.
Try to just unplug it.
Okay. Back on.
And we're good.
Good job.
All right.
Yeah. Restarting always works. Yeah. So the algorithm magic behind this
interested to know more, you can go back to where you download the OpenRefine, and there is actually like a sections that talk about the algorithms. I hope I can pull it out. Yeah, so I think match data documentations, I think yeah, if you're interested in it, you will have to slowly go through these things and find out where they are talking about the how they do the clusterings of the text. All right, anyway, I didn't really want to go do the mass edit. I can come to the undo redo tab and undo one set of it. Okay, I'll go back to the version where I have 290 counts for my Amphis pizza bilineata. Now, if you hover to this particular spelling, Amphis pizza ciliata, if you look close enough, there's actually a space behind. So I'm sorry, I couldn't. Huh? Yeah, I couldn't enlarge it because when enlarge it, the whole thing, yeah, because it's not. Sorry. Okay.
Real quick, how did you actually do the undo?
Okay, so if you go to the undo redos, you can actually choose like, so number 3 is where I did the mass edit just now. So you click back to 2, it will undo it. Yeah. Yeah. So you click to number 2, it will sort of like undo the number 3. Oh, you just well, that's called redo. So you will have you will need to come back here and click on the number 3. Then you will undo the undo, which means you redo. Yeah.
What if I want the undo step 1 but not?
Oh. No, unfortunately not.
Just go higher.
Maybe there's a way to do it, but yeah, I'm not aware of. I'm sorry. Right. So another major function, as you can see here, facet and filter. Oh no, wait. I'm sorry. So if you hover around here, you see that Amphis pizza ciliata. There's a subtle and a small space behind it. Okay, if you look at other entries, there's no space behind it. There's another very common data entry problems. Sometimes we just like to add an additional space behind some of our cells or entry, but in some other case, we don't add that particular space. For computer, again, computer says, oh, this one has additional space. They treat it as differently from one that without space. It's a very, very common mistake, and I've done that a lot of times. So it's something that we need to be careful about when we do text entry, data entry as well. And in this case, if we can suspect, I mean, you don't even need to think about whether or not there are any of such cases. We can actually just say, yeah, okay, I'll do something about it. how do we do it? We can actually go to the specific name. If you click the drop down, sorry, I need to look at cheat sheet. Boom, 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 boom. Yeah, okay. That's because everything is in common transform again. So we can go to edit cells. Again, there's a common transforms. And one of them says trim leading and trailing white space. And that will kind of deal with the problems. So when you click on it, you see that text transform on one cells in column scientific name. All right, and that's basically dealing with that particular problem. So now when you go back to this particular value, there's no space behind it anymore. All right. So these are very common mistakes, and using OpenRefine, you can simply click trim leading and trailing white space, and you deal with the problems. Okay. Let's see. There are more actions that I can do. Say, for example, right now I don't like being two words. I want to separate them. So if you know scientific names, the first words is genus. The second words is species. Right. So we can also do that here. You can go to the drop down and say edit cells again. No, this is edit column because we want to separate them into two columns. That's why you go to edit columns, and you can see the first choice is split into several columns. So you can click that. By separator. In this case, it's not by comma. In this case, it's by space. It's just one space that we can separate it. Working. Would now be empty because there's no longer this particular column here. Right. This for demonstration purpose. We will undo what I did just now. And now the scientific names facets has something in it now back. So we essentially undo what we just did. So there are some of the usual spreadsheet kind of functions, for example, filtering, that we can do here as well. If we look at scientific names again, the facets. So we use the button, we use the edit link before, but we haven't talked about the include. So what happens if I click include? On the right hand side, you see that, on the right hand side, you see that only these particular entries with this particular scientific name is included now on your right hand side, the data table right now. And you can see that there is now only 46 matching rows. And you can use this to do data filtering. Now, there's also another way of doing data filtering, not only based on the facets that you created. We can also look at the facet. No. Wait, I'm sorry. This instruction is so unclear. Oh my gosh. Change. Ooh. Text facets. Text facets. Include and exclude. Oh, okay. Yeah, another way of doing text filter, well, is to go to the drop down of the scientific name, and you can see a text filter button here. So when you click on it, there's a new interface down here to the bottom left corner. For some of us, you may not be able to see it. For example, I'm only you can choose the type of text that you want to include and exclude in this text filter. For example, BAI. Again, our right-hand side table now reduced down to those with scientific name that contains a BAI. Okay, and when you look at the left-hand side, the facet, you can see that them. AI in it, and that's why it's also being included in this filtered table. Right. So this is to showcase how OpenRefine can also do filtering like this, and if we no longer and close it. Rows. Filtering and clustering, changing things. One of the very important numbers is these things. This is my full set of data, 35549. So when I do some filtering, I expect the number to be smaller. So sometimes when you do filtering, when you look at the number of rows, it's not some numbers that you expected. You know that you may have screwed up something. So this is a way for us to QC ourselves. What have we been doing? Are we doing the right things? And this number of rows is a very useful things to look at.
So now, a little bit of exercise. Let's convert columns that you think is numeric. So say, for example, month, day, and period. Do you still remember how to convert them into numeric? So on top of month, day, period, let's also try to convert, say, survey ID to numeric. What would happen? What happens if we convert text A, B, C, D, E, F, G, H, I, J, K into numeric? Yeah, but if you do it, what does it say?
Convert 0 rows.
That's right. Yeah. So that's something that helps yourself to QC. If you convert something, but it says transform zero values, you know that something is wrong. But what happened is, say for example, if you convert something and it says transform 10,000 row, then you know that, okay, something is really wrong here, because there are 35,000 rows here. Only 10,000 is being transformed. And that's where you want to go and check what's going on. So I'll show you here again. And the good thing about you can see up here, it says text transform on 0 cells in column survey ID. Let's say you do this on multiple columns and you didn't really read this message. You can still go back to undo redo tab, and you can see that over here it says text transform on 0 cells. And that way you can sort of like, okay, something is wrong with these numbers. Let's do something about it. All right, and this is I think one of the most valuable part of OpenRefine is that it records every single things of what you have done to your data, and it will tell you. It doesn't tell you that something is wrong, but when you look at it, you know that something is wrong. Why am I text transforming on 0 cells? Must be something going on. All right. Now we have do all these things. I'm going to show you one last thing. So this can actually be turned into scripts. What we have just done to our data can be turned into script. And we can then apply the script to another set of data, or we can create another new project and apply the same set of action onto another set of data. Okay, and that is why we say that we want to use tools like OpenRefine as compared to using Excel. Okay, because in Excel, you have done 10,000 things on your data and you would not be able to do it again. So in nowadays, the environments, research environments is such that we want open source, open access. We also want our work to be reproducible. We want other people to say, oh yeah, I do the same thing as what you did and I get the same result. You know, you are a good researcher, you know, with integrity. So how do we extract the script? You can see the extract button. Over on the left-hand side is all the actions that you have just done. You can click to include or exclude these particular actions from the script. And over at the right-hand side is the script itself that do the actions corresponding to the left-hand side of all the actions. All right, these scripts are, come on. Yeah, these scripts are written in a JSON format or JSON, JavaScript. I don't know. Object notations, yeah. And what you can do is copy and paste. Copy, I can open a text edit. New document. I can paste the JSON code. And then let's say we're done with this current project right now. How do I close these things? Close. Okay, so we're done with this project. We don't want to do anything with this project anymore. Let's close it. Sorry?
When you were extracting, you said the left matched with the right.
Yeah.
But if you unselect some columns of the left, the right doesn't update.
The right doesn't update?
It didn't update.
Scroll down more. Because
I scrolled. I unselected all and the right didn't disappear.
Wow. Anyway, yeah, I'll have to look at that. Yeah. Yeah, I'll check that by creating a new project. So I click on the top left button. We came to the create project, and now I'm gonna do what I've just done. Import the CSV file that we downloaded just now. And click next. Updating preview. All right. Everything looks all right. This time round, I call it Porter Rodents 2 create project. Okay. So this is the original data set. No action has been done on it yet, because when you click on undo redo, you see that nothing happens. Infinite undo history. Don't worry about making mistakes. Every change you make will be shown here. All right. So over here, you can see that there's an apply button. If we click on apply, we can actually copy and paste the JSON script that we generated just now and perform the operations. It will do exactly the same things. It will show that 5 steps has been conducted on these sets of data. Mass edit 1 cells in column scientific name, so on and so forth. And so I think this is by far the most important part of OpenRefine, is where you can create scripts like this. And I was showing you, we applied the same things onto the same set of data, but you can easily choose another set of data and apply the JSON scripts onto those sets of data. Okay, as long as they are compatible, those actions will be repeated onto the different data sheets as well.
So compatible, that means the spreadsheets are the same exact format.
Right. Yeah. Sorry, what did you just say again?
So like to apply the same, like if you were to copy the commands,
right.
The data would have to be, or the spreadsheet.
Yeah, you will have to have the same column names and the same kind of structures, data structure. Otherwise, something funny will happen. Yeah, but of course, if you know enough about JSON, you can look at the script and actually change the attributes here according to what you need. All right. So very much about OpenRefine. I want to test out the extract again. So what happened if I remove the last action? Okay. Oh, okay. Yeah. Okay. Okay. Yeah. So again, this way we can ensure that, say for example, you have 100 of CSV file that has the same kind of data structures and you want to apply the same action to every single one of them, you can do it this way. But apparently you need to click 100 times. Not very ideal. And that's why we learn about Python. Because scripting language means that you just need to change a little bit of the attributes and you can rerun the script again. Voila, you have a new set of data to work on. And so that's the end of the data section. Next, in the afternoon, we'll talk about Python, some of the basics of the Pythons and how we can use Python, how we can import and export. I think import the data into Python, the CSV data into Python, and then do some manipulations, very much explorations as well. And I think tomorrow we are looking at visualizations and whatnot. All right, so we have a little bit of time. Any questions? If you don't have any questions, and before we go to lunch, can you write down something on, I don't know, the green sticky notes or the red sticky notes, what you think about what I've been doing for the past 2.5 or 3 hours? Good, bad, let me know. Yeah. Yeah, force yourself to think about one good thing.
Don't leave it where you are sitting, that will be take our tea.
Yeah. Yeah.
So do you collect them in each session, in each session? Yeah, we hold on to them and keep them. Okay. So if everyone could just paste their CVs here, that would probably be it. Does that make sense? Yeah, that's it. Unfortunately, yeah. Otherwise, people will have to pick up their CVs. And
It's all right. I mean, there's the answer.
I will know who wrote what once. We need like a really fast I think we probably have enough to give out one more round of green ones, and then we'll do. Maybe do green or red this time, and then whichever one, just replenish your own.
Yeah. We'll get this.
Yeah, it's all right. Yeah.
Yes, you have.
The purple could be blue and the orange.
Yeah, orange. Yeah.
If you need pen, there are pens here.
Are there instructions for lunch that you want? So I guess we can go check and see if it's outside. I think that basically we'll just line up. The lunch is going to be served right outside the door here, so we can just line up around where the registration table was, and then we'll come back in and eat here. Actually,
And do you recommend that people leave their stuff here in the room, or?
I think. I mean, we're going right out the door and coming back in. So assuming you're okay with leaving your laptop when you go to the bathroom, it's probably okay.
So, are we still fixing the power problem?
It's fixed.
Oh, it's fixed.
I'll take a look. Is there anybody who doesn't have power at your desks? Okay, so we'll check these.
Yeah.
And see if we can get it.
Yeah.
fixed.
All right, thanks.
I think you did a really good job.
I was like, yeah, I was a bit confused about the later part. I was like,
No, I think it went very well. So
oh,
good job.
okay, thanks. Thank you very much.
The pace was good. Wasn't too fast at all.
Yeah.
It wasn't super slow either.
Yeah, but also because I think the materials are quite simple.
Yeah.
So that's fine. Yeah, we'll see.
Yeah, the only thing was this font size. Like you have to remind me also to do the same.
Oh yeah. Yeah, I keep forgetting about it.
That's
So,
okay.
yeah.
I forget too. So don't have, because here it looks really big, like on the screen, but there
It's
pretty
not so
small,
big.
yeah.
Yeah. Whew. The food. Yeah. What? I mean, was the traffic bad or something like that in the morning?
No, it's just the parking is far away. So I got here at 7:55, but I parked like 15 minutes here.
Oh, yeah. Wait, really? So, no, yeah.
So I had to walk up. That's okay.
Okay.
I didn't plan for that.
Yeah, I know. Because I was walking to it. I was walking
How far away are you?
about 20 minutes. Yeah. So it wasn't too bad. Yeah. It's just it's a little bit of a queue. So
Yeah.
it's okay. Did you have breakfast?
I did.
One thing about the cafeteria shop is that because there's usually a break usually you have some pastry as well.
Yeah.
So you cannot feel like
Pretty
actually
full,
not hungry. I'm actually not hungry.
And especially after teaching, you're
Yeah, you're actually like
so your appetite is better.
okay. So you want the I should.
All right. So what's happening with the recording?
The recording died a little.
Yeah. If it didn't work, that's okay. I'll record my session, and if that doesn't work, we'll record tomorrow.
Yeah.
At least one of them will work.
Yeah.
So